This video is a collaboration of the International Fire Stop Council, a not-for-profit association dedicated to promoting the technology of fire and smoke containment in modern building construction, and UL, a premier global safety science company dedicated to evolving the future of safety. Structure fires have tremendous consequences. Proper understanding of fire containment standards can save lives. According to the National Fire Protection Association, in 2010, structure fires accounted for only 37% of fires, but 85% of civilian deaths and 84% of direct property damage. In numbers, that's 2,755 deaths and $97 billion in property damages. Optimized fire protection requires a comprehensive approach, including careful attention to passive fire and smoke containment. This video focuses on containment through the installation of tested and certified code-compliant systems in wall, floor, ceiling penetrations, and joints. It is critical to keep in mind that effective fire stopping requires accurate adherence to a precise combination of components and conditions that have been tested as a system to determine their fire resistance capacity. These listed fire stop system components include the penetrated substrate, the size and material of the penetrating item, the size and shape of the penetration hole, insulating materials and sealant, and the quantity, type, and installation method for the full system. Deviation from any of a listed system's components severely compromises the overall effectiveness of the fire stop. Incorrect fire stop installations are unfortunately too common, and in the event of a fire, the consequences could include preventable, dangerous exposure to fire and smoke for egressing building occupants and responding firefighters, as well as excessive property damage. The test scenarios featured in this video were created in UL facilities and designed to simulate realistic room configurations and fire progression. Each scenario includes a matched set of penetrations and joints, one that is fire stopped correctly using a UL listed fire stop design, and one that is fire stopped incorrectly using an unrated design. All correct materials and installations represented in this video comply with UL 1479 for penetrations and UL 2079 for joints. These initial scenarios illustrate a very common mistake. While fire stop sealants have been used in the incorrect installations, they're not the appropriate products specifically listed for these applications. In the case of the plastic pipe, the non-compliant installation results in a complete failure of fire and smoke containment within a short time. For the tested cable bundle scenario, the non-compliant installation resulted in a considerable amount of smoke passage within a short time, due to the fact that fire stop putty listed as part of some tested cable penetration systems was used in a way that did not fully meet the tested system's installation requirements. Attention to detail is critical. In this scenario showing a copper tube, the installations are identical with the exception of the insulation material. Use of the non-compliant insulation results in rapid spread of fire and smoke and demonstrates the importance of matching every detail to the listed system. Even materials with respectable fire properties will not hold up if used inappropriately. The hole for the 5 conduits on the left uses glass fiber insulation, a material that does well in non-combustibility, but in the event of a fire, softens and yields considerably. Its lack of suitability for this installation allows smoke and hot gases to pass rapidly through the fiberglass stuffed openings. The temptation to use materials already on hand, combined with lack of knowledge, can result in inadequate fire stopping. Here, a common foam-type sealant found at most construction sites is used to seal the pipe on the left. There are no tested and listed fire stop systems using these common foam sealants for fire resistance. The foam sealant was completely burned away. On the right, a fire stop system was installed in accordance with the system listing, and fire and smoke passage were completely prevented, as expected. The fire safety danger of using readily available materials far outweighs the convenience of using these materials. This final scenario shows the critical importance of correctly fire-stopped top-of-wall joints. This schematic shows a plan view of the test setup. The compliant and non-compliant joints were located next to closed-in areas to simulate adjacent corridors, which are often critical for effective egress from a burning building. The non-compliant top-of-wall joint seals are ineffective and allow massive amounts of hot smoke to move through the unprotected joints, quickly filling the space on the non-fire side of the wall with smoke and hot gases. Conversely, the tested, listed, code-compliant joint seals are able to contain the combustion and protect the adjacent space. In this situation, safe egress would be possible. Adherence to listed fire stop designs using specified proper materials and installations saves lives and makes the world safer, ensuring that people and places are protected more effectively. Whether an architect involved in specification, a contractor involved in sourcing and installation, or an inspector whose job it is to recognize and improve compliant materials and installations, it's the responsibility of all involved in this process to be sure that they understand the importance of following listed systems and make it their business to comply with tested, code-compliant fire stop solutions. To learn more, contact the International Fire Stop Council, or UL.